Today actually we are going to discuss about the second parameter, that is environmental factors, which will decide the rate of corrosion. There are many aspects of environments which will affect the rate of corrosion, and we will discuss one by one. The first one is actually diffusion. All of you must be knowing what is diffusion. Let us give one example to make you understand. Suppose somebody is sitting at the back and I have a spray perfume with me. If I spray perfume over here, immediately the student sitting at the back will not get the smell. But after some times, the student sitting at the back will get the smell of perfume. How it is possible? It means the perfume molecule from this place has traveled to that place. It is a spontaneous process, it is a natural phenomenon without undergoing any chemical change, mixing of gases and traveling from higher concentration to the lower concentration. It is a natural phenomenon and it is known as diffusion. And diffusion plays a vital role in deciding the rate of corrosion. Actually, in majority cases, rate of corrosion is controlled by diffusion of reactant to and from the metal surface. All of you understand that a freshly prepared metallic structure, if you put over there, it will corrode faster than a metallic structure if it is actually having a layer of rust over it. It is all because of diffusion. Because the metallic surface which is having a layer of rust, through this, the diffusion of oxygen will be slower than that of a freshly prepared metallic structure. Diffusion of oxygen through water, actually we should say like that, the rate of corrosion is heavily controlled by nature of diffusion rate of oxygen through water to steel surface. Suppose there is a steel structure under water, oxygen is there. How quickly oxygen is getting diffused through water to the surface of the actually metallic structure, the steel structure, will decide the rate of corrosion. Actually, in area where diffusion is prevalent, I mean diffusion of oxygen is prevalent, rate of corrosion will increase over there. No doubt about that. The area where rate of diffusion of oxygen is low, corrosion rate will also be low. High flow area. You must be knowing in civil department, in civil work, we use a word. It is known as actually bell mouth, It is actually a metallic structure having a bell structure at the front, and then slowly and slowly it becomes narrow. In the vicinity, if we take an example, I have told you bell mouth. In the vicinity of the bell mouth, the rate of corrosion will be very, very high as flow of oxygen is more at the bell mouth. And therefore, these are the different aspects of diffusion which will decide rate of corrosion And now let us discuss the second point, that is your temperature. Actually, all of us know that rate of corrosion is directly proportional to diffusion. It means if the rate of diffusion is very high, rate of corrosion will be very high. If rate of diffusion is low, rate of corrosion will be low. That is why it is called directly proportional, and diffusion rate is controlled by temperature, and therefore under deck area and the region adjacent to the engine room or heated cargo tank, rate of actually diffusion will be very, very high, resulting higher rate of corrosion. Sulfate and sulfur containing ion generally initiate this kind of actually increment in the rate of corrosion, and this sulfur ion may be originated from inert gas system which are being used in the different area, and cargo containing crude oil. As all of us know that in crude oil there will be huge amount of sulfur producing compound or producing sources, and therefore, as I have told you, sulfate or sulfur containing ion will promote by initiate this kind of corrosion, and therefore these are two different areas which I am talking about. That is, this sulfur ion may be originated either from gas, inert gas system, and cargo containing crude oil. Now, third point I will be talking about your conductance. Conductance of corroding media. See the third point, the conductance of corroding media. For corrosion to take place in a submerged or underground structure, underground system, conductance of media plays a vital role. As all of us know that conductance in a dry, sandy soil will be very, very low compared to that of actually clay soil or mineralized soil, and therefore any structure buried or submerged in clay or mineralized soil will undergo faster corrosion rate compared to sandy soil. This is all about your conduction of corroding media. And fourth point is pH effect. This is very, very important. As all of us know that pH is actually a measure of acidity or basicity in the scale from 1 to 40. You know that. Generally, pH 7 means it is neutral. And in general, sea water generally have pH value 7.5. And therefore, it is almost neutral. And therefore, in such a situation, how a metallic structure made of iron at pH 7.5 will undergo corrosion. But here, the dissolution of iron is mainly because of the reduction of oxygen concentration to H- ion. The oxygen available dissolved in water at pH 7.5 will undergo some kind of changes producing hydroxyl ion. And if the acidity of water increases, I want to mean if pH goes down, rate of corrosion will be immediately increased. Now, if your environment becomes more acidic, it means your environment will have excess of H+ ion, which is being released in the form of hydrogen. We have seen the mechanism. And actually, rate of diffusion of H+ and H2 are very fast, and therefore rate of corrosion will be very, very fast. And corrosion rate of iron in oxygen free water is very low, much low, until the pH of the solution, pH of water is below 5. And in presence of oxygen, rate of corrosion will increase drastically. If you have a metal or metallic structure which corrode very fast in acidic environment, it can be controlled by increasing the pH of the water by pH of the environment. For example, we know that zinc, rate of corrosion of zinc at pH 11 is very slow, very low. But if it is brought in contact of an environment where pH is low due to the even presence of weak acid like carbonic acid, rate of corrosion become very fast. And this is all about your pH effect. And today whatever we have discussed, you might have understood. If there is any confusion, we will clear it in our next lecture. And I hope you will go through the video and try to understand everything.